I'd like to call this meeting of the Brew Robotics Club, September 24, 2025 to order. And we'll start off with robot news, industry news. Do we have any industry news anybody like to talk about out there? Hey, Jim, good to see you.
Hello.
I've got something I want to share. I think we talked about it last month, but I don't know that we really covered it in detail. But they did that. Let me share my screen. But they did that humanoid games in China this year, and it was a big deal. And they're going to do that again next year. And it sounds like they're going to be doing this humanoid games every year. And it's too bad that we couldn't have made robo games that, but that thing's getting up and away. So again, I know we talked about it last month, but let me just play a little video from it. Bear with me. Chrome tab. Second. I'm going to try to get the audio here. Bear with me. Also, share audio. Also, share audio tab. Okay, let's try this. Let me turn up the volume. Oh, no.
Government is hosting this 3-day event. Humanoid athletes show off their skills in martial arts, the 400-meter race.
Is it just me, or does that guy look tired?
And rounds in a soccer tournament. Guo Tong, who programmed one of the futuristic footballers, sees robots replacing his idol Ronaldo.
By when?
2050, he replies. Robots have stronger joints and core strength, he explains. Chinese Olympic boxer Li Yang trained this robot to fight in sports, but at jobs too, as drugstore clerks, factory workers, and hotel housekeeping.
The challenge is for the robot to pick up all the garbage that's in the room, but the referees tell us the biggest challenge for the robots is opening and closing the door.
This isn't just fun and games. Beijing has plans to build a world-class industry of humanoid robots by 2027. Designer Wang Xidong says the competition is key. We are refining our robots, he says. Everyone feels motivated to compete. As China attempts
Test 1, 2. Can you hear me?
Yep.
Let me share my screen again here. And let's see here. Home tab. Yeah. Some of you know Andre K, and this is something that she had to say on LinkedIn I thought was pretty interesting.
Once again, it's taken 20 odd years for humanoids to become an overnight success, but we really needed a certain critical tipping point to reach for humanoids to have this moment. And those of us that have been enthusiastically following companies like Agility Robotics, Aptronic, 1X, Fourier, Unitree, Deep Robotics, we've watched them get commercial trials and in the case of a couple of them, go from commercial trials to actual commercial contracts. And now that is a significant step. That's opened the doors to say there may be a business case for humanoids now that wasn't previously possible. And here's the thing. If you remember what a mobile phone looked like in the I think it was around 1987. Now, they never got bigger, heavier, or more expensive. And that's what we need to think about with humanoids today. They are never going to be any worse than the current state of technology. They are going to continue to improve. They're going to get more capable, and they're going to get more affordable. They're here to stay because the range of use cases for them is pretty broad. I think I've come up with about 11, maybe 12 different business models, business use cases for humanoid robots.
Yeah, so that's kind of interesting. Cell phones never got bigger, heavier, or more expensive, and humanoid robots are as bad as they're ever going to be, okay?
The more expensive part is probably not true.
Say that again?
The more expensive part is probably not true.
Oh, shit.
Yeah, but they added lots of other devices into the phone, so maybe that
Yeah.
counterbalances that.
It depends on what you're doing. You can buy burner Android phones that are better than basically any phone from 2010 for under $40 nowadays.
Well, I had a moment when I was working at that AI conference with Kovar Life. I was doing I was replacing the shin on the G1 humanoid, and I did a head transplant on the quadruped dogs. And what was this? It was in like San Carlos Community Center, San Bruno. It was one of those community centers, really swank. But he had the humanoid robot sitting there in the wheelchair, you know, and the quadruped dog, and just like Andre was talking about, you know, phones 40 years ago, I'm looking at this humanoid robot and this quadruped dog and thinking about computers back in the 80s, you know, when you had an 8 megabyte hard drive costing $4,000 and was the size of a suitcase. So the humanoid robots aren't going to get any worse. Let's see. Also, I picked up on this. Let me share the screen again. It looks like Construct has a G1 training class now certificate. So I thought that was interesting. And I did a Google search, and I want to get into, you know, do something with humanoids. So I'm looking at this. Has anybody tried Weebots? This seems like a good beginner's simulation kind of thing. But has anybody tried Weebots? I think the other one was Muku. What's the other simulator? Mukoju, help me out here. What's that? What's the others? We all know Gazebo.
Yeah, it's like Mujoko, something like that.
Mujoko, yeah, that one. But that one, it seems to be more advanced. But anyways, I'm gonna try to play around with some humanoids in simulation somewhere. Is there any other industry news somebody'd like to share out there? Going once, going twice. Okay, let's go to club news now.
Well, there was a mention today on the news on the Major League Baseball is going to have a robotic umpires next year.
I caught that headline too. Yeah, okay. So
it's basically a camera system, but apparently you get to second guess it twice in the game, and you better be right.
well, are they still going to have actual umpires and use this as a backup, or is it going to make the call?
It's apparently it's going to make the call, but of course everybody's going to be watching it.
Yeah, well, I mean, what does the actual umpire do then? You need him just to stop the fights, right? Physical fights.
Yeah, he's the padding between the players when they try to beat on.
I, I think I read that it was, or what I got out of it was that it was to help speed up when there's a disagreement with the umpire.
Okay,
So
you can phone a friend, but if the friend's wrong, well, I don't know. I guess you get a limited number of phone a friend kind of things.
Ooh, yeah.
All right, do we have any other industry news out there? All right, let's move on into club news now. We had a Robo Magellan event in the fall. Somebody want to talk about that?
Yeah, the same suspects had basically a good time at the park again. Not too many new pictures, or I still have the logs of it, but otherwise, yeah,
There you
not
go.
too, not
That's the
too
main
many.
shot there.
Not too much difference from basically
It's
the June
it's quality,
event.
not quantity, Marco. This is awesome. We want to try and do Robo Magellan events when we do our challenge events. And without
Yeah.
a deadline, nothing happens. So this is a deadline that you can build towards. And other
Yes,
folks building, and Robo Magellan's an awesome event. I mean, it's
yes, please come out and try it. It's fun.
yeah, yeah. Robo Magellan, you get at an actual practical application of a full-size robot. It's not a fighting robot, but I mean, if you can build a robot that can reliably get to a GPS location, there's something there. It's all about delivery, and the Robo Magellan is just an awesome contest. So here's something you can build towards. We do our challenge meetings in March, June, and September. It is September. And so, yeah, it takes several months to build a Robo Magellan robot. So get started on it, and we'll see you out at the park in March, right? Right, Marco?
I think so, yes.
That sounds good. All right.
Who
We don't
won?
have, was a comment out there?
Were there any winners? How did that go?
Everybody that participated won.
Yes.
Hey,
I
okay, everybody,
think
did everybody actually touch the goal cone? Could they touch the cone?
yes. We all touched cones.
Autonomously?
Sorry?
Autonomously?
Yes.
Okay, just have to check. Hey,
Important
wait a minute.
caveat.
What okay, I get the small one, I guess. That
Yeah,
looks like a table. That looks like a tabletop robot. It actually managed to navigate on the grass.
not really.
Not
I
really.
didn't even get her name,
Okay.
but
Okay. Very
she
good.
came out and at least tried it and talked to
Okay.
us. And yeah,
Did it have a GPS on board?
I don't think so.
Okay. Okay. That's awesome. She came out anyways. Okay.
Yeah, but you
Maybe
have
she-
to start somewhere.
No, all of it. And even then, I mean, these things, come to it. There's tables there. You don't have to have a Robo Magellan robot. You can bring your other robot and show it off and ask questions and stuff like that. So it's awesome. Very good. Very good.
Do you guys allow GPS RTK?
Does that,
Not any longer.
everything has to be on board the robot, right, Marco?
Officially no, but RTK is officially not allowed any longer.
Okay. I think they said something about, and this is the Seattle rules, but I think they
Yeah.
said something about allowing off-board compute, but I think it was more about a workstation for Ross. You know what I'm
Yeah,
saying?
it's more basically for path planning or stuff like that to
Right.
allow for bigger compute power.
Yeah, yeah.
So they officially disallowed RTK solutions.
Yeah, so generally everything needs to be on board, but they'll allow you a workstation. What's going on here? Okay, moving right along. Oh, we got Maker Faire. We got Maker Faire coming up on the 26th and 28th. Marco, we'll talk about Maker Faire.
Yes, I will be there, and Raphael will be there, and Stephen will be there on Saturday, and Nathan will be there. And
I will be
got
there.
my sorry,
Dee Dee will be there. All right.
Didi will be there, and the other Stephen will be there.
I will be there.
And yeah, I got my wife to join me on Saturday and Sunday as well.
Back from Europe.
She is working again, yes.
I like her photos. Very nice. All right, that's Maker Faire, September 26th to 28th. So check it out. That's where's that going to be? At the what's the location?
Mare
That's
Island and
Mare Island,
near
Vallejo.
Vallejo.
What island?
Mare Island,
Mare Island. I know that one.
M-A-R-E.
Very good. Okay, so that's this weekend,
Yes.
starting Friday. Okay, moving right along. Is there any other club news? Okay, if we don't have any more club news, let's just go into the presentation this evening. The presentation this month is our challenge month, so it's all show and tell. Let's see, let's just start this off with 23 years ago, we were lamenting the lack of building going on in the club, and we're sitting around in the Cupertino library, and we thought, let's do tabletop soccer. We could put nets around the table and have the robots, try and play soccer on the table. But that would involve setup and having to set something up and lug it around and so forth. And that's when it was born, the TableBot. A TableBot's a robot that survives, lives, and plays on the table or pays the price. Shortly thereafter, we opened up other challenges, including the FloorBot challenge, got ArmBot challenge, AI bot challenge, and of course the ever popular Run What You Brung. So this is your own special one-of-a-kind robot. I'll go ahead and start it off. I've got a TableBot over here that should be able to do a phase 2. Thomas, you're out there. Can you highlight me? Can you highlight my robot?
You are highlighted.
All right, here we go. Okay, so I got a robot right here on the table, just a random table, okay? I'll switch this robot on. It does like 2.5. Let's see if it stays on the table. We got dogs barking. Very exciting. Oh, he almost got a phase 2 there. Come on, robot, you can do it. He wants to do it very badly. And we'll put it over here. Give it a flat surface. There it goes. You boxed it off. Come on, you can do it. Yes. All right. There's a phase 2. Thank you very much. We're not proud. Okay. Does anyone else have a table bot out there they want to show?
No,
Does
but
anybody else?
I would like to show soon just because I'm trying to get ready for going to the Maker Faire tomorrow.
Very good. Go ahead, Dee Dee, you're on.
Okay.
Yeah.
I'll move the
Maybe
camera.
you'll find spotlight.
I can't see myself well, but there is the updated humanoid. Let's
What's
see.
that robot's name?
Well, this one's a silver in move, and the other one is the white in move. We had names for them before, but it was too confusing. So we just named them by what color they are.
That's good.
So,
Easy to identify.
so here's the white one. And if you, at some point, the mouth will start moving. But yeah, the eyes move around. And yeah, you can see the lips moving on and on there. I turned the volume all the way down, but it's doing a poetry jam. So
Does that have rubber skin?
yeah, it's silicone. So
Nice, very
Wow.
nice. I'm impressed.
yeah, so on
Mm.
the website for InMove, they have how to do the silicone skin. It was definitely challenging, a lot, and even some parts were so difficult, like at some point, like the connection between the silicone and the head doesn't look great, so I just put a hat on it.
It
because-
looks awesome.
so,
It looks creepily awesome.
yeah, and the nice
We're in the uncanny valley.
yeah, and the nice thing is it's like not a natural color, so it looks not as human as it could be, which is good. It looks like a
Okay.
statue or something.
Yeah, I like those eyes.
Yeah, so
Awesome.
I need to do some touch-ups for the Maker Faire, but I figure I'd just show.
So they're doing some poetry jam.
Yeah,
Very
they're doing
nice.
poetry jam right now.
That's awesome, Dee Dee. Let me give you a big round of applause here.
Okay, thank you. Okay,
All right. Thank you very much, Dee Dee. Love it.
bye.
Thank you very much. Okay. Bear with me. Who's next? Who wants to go next?
I can show a little bit of my attempts to basically do 3D LiDAR. So far, I didn't get to. I'm coming around.
Oh,
Um,
not this.
yeah, I'm coming. Just a moment.
This is your new robot?
No, it's basically mounted on a Zarpi. So that's basically the 3D LiDAR. And
But that's not Endecker. Is that your robot, the
No.
red one there?
no, that's Zarpi the rover. And I'm coming around and watch the little red arrows. That's basically just odometry calculated out of the 3D LiDAR.
Whose LiDAR is that?
That's a Livebox LD 360.
Are you? Oh, did you say?
LD MD 360. So now
conversation going on with IMU or anything
there is an IMU inside
in the
in the LiDAR box. So that's the only two sensors that are currently controlled by ROS. And
I'm still not understanding what camera that is.
that's not a camera, it's a LiDAR.
Okay, it's a LiDAR, and you're saying ND is in November Delta 360?
No, MD 360.
Okay, I got your M as in Michael. What is the second character?
So, sorry, I'm coming.
How about we post the name of the component in the chat?
Sorry?
How about we post the name of the component in the chat?
Yes. Yes, I will post the name in the chat, and
This is like, cool. Can you zoom in inside the building thingy that you were working?
yes, I'm going to go there.
So is this our tab map or what's relating the building?
That's basically
Dude, that's a fourth. Is that a fourth? How much is that LiDAR?
that LiDAR was about $800.
Okay. Okay.
So
I saw a $4,000 version.
so that's now basically inside.
Wow.
Doing the mapping.
It's basically some algorithm I found online.
Okay,
It's-
you implement your own.
I basically stolen was one version of it and made it work in Turkey.
Okay.
And yes, I want to use that LiDAR basically for a cost map and do more with it, but I had so many problems getting basically the network going, and currently I'm getting basically 8 hertz out of it.
Very
So-
interesting. So is that that's on that red robot there, or is that on Endecker?
No, that's basically on one of my surveys.
I see. I see. And
And that's depth only, right? No color? Or does it have color too? It says
Sorry?
RGBD. Let's see.
do you have any idea how well it performs out of doors?
Outdoors, it works up to 40 meters, or it claims to. So if you look at our
Wow.
camera, that's basically, that's the LiDAR.
Your screen is.
Wow.
Okay. So on our side, it's pinned. So I'm stopping.
Very cool.
So that's basically.
Very cool.
The LiDAR. And
Mm.
yeah.
Thank you very much. So you're like teleop keyboard now?
No, I'm not. That's basically still an RC control.
Yeah, okay. I see. RC control. Cool. Oh, okay. Radio control. Okay.
It currently has 2 Raspberry Pis on it. One Pi 5, basically handling the LiDAR, and the Pi 4 for
John?
driving it.
Young, do me a favor and get the camera and get a nice picture right in front of Marco. And with his robot. I want a picture of Marco with his robot. Marco, act like you're having a good time.
I always have a good time. That's,
There we go.
that's
All
the
right.
robot from the front.
Back up a little bit, Kyung. Can't get the whole robot. There we go. All right, very good. Thank you very much. Okay, good. What else this evening? I know I've got some guys on the East Coast, so
Hey, Camp,
yeah.
I've got my mock
Ross, you're up.
bot all fired up.
Ross Lunan from Canada, ladies and gentlemen,
Um,
with Turtletron.
oh, oh dear. Let's see. I have to turn something on here.
Screen share.
Okay.
Something on with the
That's a
robot?
good start. Now, where's the button? Where's the green button? There it is. Let's see if I push this button.
Did you mean to share your screen, or you want to?
Yeah, I'm sharing it now.
No, we're looking at your face. There we go. All right. We see your
There.
screen. I see Turtletron.
That is Turtletron. It does circles. And it's on. You've all, most of you have heard this before. But it's built on the Create base. Let's see if I can get a boot. This whole thing is mirror for me. So, oops. Let's go back there. Right, there's a Raspberry Pi 5 loaded with Jazzy, of course. This is my contribution to Camp's book. This is the this is the Roomba variant of it.
That's RP LiDAR, right?
There's an RP LiDAR in there. You can you see it's round. There's an Oak light. I'm tinkering with going back and forth as to what I'm going to do about my IMU, but I think I'm headed. I did get, I guess, thanks to Sergey, I guess it was. I used the MPU 9250, and it worked fine. It spewed the required topics, but just to keep things simple, I do have the IMU. I do have the Oak camera that has the IMU in it, so might do that. Let's see, this thing, the camera actually works. I should have put that on. It says here. The Oak camera doesn't work if there's no battery.
Details.
Doesn't seem to work if there is a battery. Well, no matter. I've got all the code written for desktop and the and the robot itself. And as I mentioned right at the beginning of the meeting with Mike, I've got the EKF Fusion node working, and it spews out 8 or 10 transforms, except the one that matters. There's no code. There's no ODOM to baselink, and so nothing works. And,
Teleop keyboard works. You're just not getting any maps.
Correct. Because when you get this far, the rule says slam toolbox won't proceed unless there's that transform is there. So that's tomorrow. Work in progress.
Thank you very much, Ross. Who's next? Who else has a robot to show? Kiram, did you want to show yours? I know you're in Texas. What's that, like Central Time or something? You out there, Kiram? Oh, there he is. Kiram, did you want to show your robot? He may have stepped away. Who else has a show and tell? Jim, are you ready?
Me?
Yeah.
Yeah, I can try to go.
Do you need some setup?
Well, I have two things actually. I can do I have a Freenove dog thing that we've seen on
Okay.
here before.
Do you need
But
any setup?
I can do orange first. Well,
Okay.
and I'll
Go ahead,
turn
pick
this.
orange.
So
Jim,
yeah,
yours is.
thank you. Yeah, today though, it's basically a a non-moving demo, but it's AI demo. So what I'm doing is I've moved the AI like chatbot stuff onto the robot itself and to the you might have seen the video I showed, or I think I showed it on this meeting last time, which is it's got a Jetson Orin Nano on board now, so it can process. It's a powerful NVIDIA GPU, and it with 8 GB of memory and a full Linux operating system, and it can consume. And it only consumes like 25 to 30 watts of power, so it's good for the edge case. So let me show you. So what I've done is I moved my chat from OpenAI from the internet to onboard for the chatting. And then for like image visual sort of language VLM, I have my own server here running with a big video card, and so the robot talks to that. It's a local server. So you should see my desktop here. Or actually, this is the robot screen. This is the robot screen.
You said big video card. Does that imply GPUs or something?
Oh, yeah, I just meant it's a 3090 NVIDIA RTX 3090 24 GB video card. And I'm running, actually, I can show you quickly. I run what's called Docker Desktop. Docker Desktop lets you run whole operating systems, uh, servers basically on your in Windows or Linux, but this is Windows version. So I have a server running virtually, or it's running as a virtual machine in here, and it is running an Olama server, and that's where my visual thing, a visual transformer or visual language models running. And so that will handle the pictures. You see, so I have code in here using a LangGraph that sends pictures to one AI and sends text to and text, and then text and tools to the onboard Orange system with the NVIDIA Jetson Nano small board. So let me just start a demo here. We have some pictures from the Maker Faire, Orange County. And so I've added a tool in the system here that lets me ask Big Orange about a photo album, and he can look at and talk about photos, and also can talk about what he sees in his camera, but this is I figure I have more interesting things to show. I have more interesting photographs than I have pictures of this room. So let's try it out. Hey, Orange. In the first photo of the album Orange County Maker Faire, what do you notice in the foreground? So this sends it to a tools agent, and it's processing on board locally. So it's kind of a little slow, but it actually the first time is slow. I should have done a pre one. And what happens is then it sends the picture. if it works correctly, it'll send the picture to the other one by using the Vision LLM on board my local server here, off the robot.
In the foreground of the first photo from the album, Orange County Maker Faire, there is a man seated in a wheelchair, smiling at the camera. He is surrounded by various items on a table, including what appears to be a recycling bin and some other equipment.
Could you hear that?
Yes, yes, yes.
Yes,
Okay.
you know, that's a AI challenge level phase 2. You got the phase 2, Jim.
All right. Now here's another
Who built that trash can recycle?
oh, this is from Walter Martinez at the
Walter built that. I recognize it. Okay.
Yeah. So we're going to ask about that right now. Hey, Orange, in that photo, what do you think the green button does when pressed?
The green button in the foreground of the photo appears to be on a recycling bin. It likely indicates that it is a push to open button, which is commonly used to open recycling bins to prevent the contents from spilling out.
Well, it's getting sort of the idea. Now I'm just going to move on to the next one. Hey, Orange, let's look at the second photo in that album.
The second photo in the album shows a group of robots and people at what appears to be a convention or exhibition. The robots are quite detailed and colorful, with one prominently featuring a yellow and black color scheme. There are also people interacting with the robots, suggesting a demonstration or showcase of robotics technology.
Excellent.
Yeah, one more question. Hey, Orange, in that photo, do you see any familiar robots that look like ones from a movie?
In the second photo, there is a robot that resembles a character from the movie Star Wars. It has a yellow and black color scheme and a design that is reminiscent of the droids from the film.
Yeah, so also of note, Walter Martinez's robot R2-D2 is in the back left corner of this picture here, this one.
Nice.
One more question to close out this. I say, hey, Orange, are there any more photos in that album? And so this is using a tool that's
more photos in the album. Would you like to see another one?
I guess it messed up that time. It's supposed to... Hey, Orange, are there any more photos in that album?
Yes, there are more photos in the album.
All right.
I'll just say the current album.
I think it lost the context. I'd have to say, hey, Orange, are there any more photos in the album Orange County Maker Faire?
Yes, there are more photos in the Orange County Maker Faire album.
It's hallucinating.
Like to see
Yeah, it's hallucinating. Basically, it's supposed to be using, see, if you look at what's happening here, I mean, I don't need to go into too much detail, but there's a thing called tool use. And the tools are how it really figures things out. Like right here, tool call, if the LLM properly figures out, oh, I need to use a tool, then it will say, like if I say, give me the picture, you know, first picture, it ends up making this call, get nth picture from album, and you know, n equals 1. That was the second. And it's supposed to do n equals 2, and then it comes back with an error and then says, nope. And that's how it worked at home, even though I am at home. So any questions about that? So this is using LangGraph and 2 different LLMs, and it sends pictures to one, and it's keeping the memory of the full conversation. LangGraph is just really great. But next I can show you the robot dog, or let somebody else go and I can come back.
Go for it if you're set up, Jim. Go ahead.
All right, so there's at least one person did the robot this free Nove dog. Like a few months ago. I forget, he's not here tonight, I guess, but somebody have to remind me. I can't remember.
So Chris Mayer?
No, it wasn't Chris, but so I put this thing together. And I brought this to Maker Faire to show off. So it has it's an okay kit. It's like it takes a lot of build time, or not that bad, but it's got a nice app on the phone here, if you can see, with controls and everything. And so, the first thing, of course, you want to do is, well, I can, move forward or whatever. It doesn't walk that great. Oh, and you can go faster. It actually, this is the same problem that he had. It moves backwards better.
Maybe they put the head on the wrong end.
Is this the speed? Oh, that's I can make him go up and down, like tall, and this is the speed, I think, here. Oh no, can make him move his head, and then let's try to go forward again. Where is this? I forget where the speed is. Oh, maybe it's here. Yeah, speed can go up. Oh, I'm not showing you. I should
Let's get
screen
ready to
share this
move.
thing too.
Ooh.
He's supposed to work. This is just the sort of, I didn't have to program anything. This was their given program. And it's supposed to, but yeah, it's kind of clunky. It has a camera though, and
Yeah, but you need to calibrate your servos.
yeah, I
Otherwise it
calibrated. I calibrated them all according to their
Ah,
thing. It's
it should
he
work better.
he has like a slightly limp. One of the servers. These servos are not the greatest, and some of them are not really strong. One of them was defective. What's also cool is you can do this pose control, which is, see where my fingers is here. You can manipulate it and have him go up, and it's oddly, sort of organic, like he also balances. There's a balance button, and it works okay. So if you put him, I don't know if you put him on a box or something. This isn't big enough, but so balance. So this is balance mode. Can you see this?
Does it have an IMU?
Yeah, it's got an IMU. I don't know if you could.
What's the robot's compute?
So he has a Raspberry Pi 4B as the main CPU. I don't know if you can hear it. He's adjusting the servos just a little bit.
Yeah, we can see him adjusting. That's cool.
Yeah, so that's pretty neat. And he's got, of course, the light effects, you got all that kind of thing going on. And then, the video, well, yeah, he's got a video. But anyway, yeah, it's, I guess, interesting to play with, but I'm not that, I'm not that impressed, or I guess I need to look at some more videos.
Slay's got some neural problems.
Yeah, I need to do something to work on a better walking, whatever, or get better.
Gait.
Yeah, I mean, you can see how it's very simple legs, and it's just the servos are very lightweight servos. So I don't know. Yeah, if anybody has some advice on like where I should look outside of the normal manual, or outside of the normal sort of place, then and he has to take a rest after 3 minutes of use. They like build it in to prevent the servos from overheating or something.
It sounds like they need to up their servo game.
Yeah, the servo, But this is like it's the first time I put together something with legs. So and that
What
many.
does that, what does that cat cost?
And this was like only $120. 100 and
Okay.
oh, is that
Oh,
backwards? Oh,
the dog. I thought it was a cat.
it is kind of a cat. It's got
It's a dog cat.
I don't know. It's a dog cat, but yeah, we've seen this before on you know here at the meeting. But yeah, so thank you. That's it's
Thank you very
basically
much,
that.
Jim. That's awesome.
Thank you.
All right, let's keep the show rolling. Who's next?
I can make an attempt.
Who is that?
This is Kareem.
Kareem, go for it.
What would you like to do next?
Oh, I need this. Let me,
Something else?
be quiet, Barney. Just a second.
I didn't understand that. Did you do something with my camera? My apologies.
Go to sleep.
Let's try. Can I help?
Kareem, you're not showing anything.
Yeah, no, I'm trying to get I got everything reconnected here. Okay, let's see. Are we showing my camera? Are you
Wow.
seeing my camera?
Yeah, that's the scout.
Yeah,
isn't it?
Yeah, so you can see my robot here?
Yes.
Okay, so this is a P3 AT chassis. And again, it was like all the rage back in the early 2000s and a little bit earlier than that, perhaps. So it was produced by, it's a Pioneer 3. It's the four-wheel drive outdoor version. It's just skid steer. I've got a wave share row arm M2 on the front of the robot, and there's a D450 RealSense D455 camera right there. This is just some superstructure to hold up the antennas and such for RTK, and so on board it's running ROS2 on a small 4 CPU box, a NUC, and so what I've been doing is a little bit of some AI experimentation. So I'm gonna be fiddling with its microphone, turning it on and off so that it pays attention. But let me make sure you can. I'm gonna try and put you on a different microphone. Tell me if it works. Should be on the webcam microphone now.
We can still hear you, yes.
Okay, good. All right. You should be able to hear the robot a little bit better as well. So, hi, robot.
You mentioned you needed to see something a second ago. What can I help you see?
What's your name?
My name is Barney, and I'm a skid steer robot.
Can you tell me a little bit more about what you can do?
I can move my base forward, backward, and turn. I also have a 4DOF arm with a camera that I can use to look in different directions. I can also track objects with my camera or follow them with my base.
Cool. Let's see you move your arm. What commands can you accept?
I can move my arm to a few preset positions: bumper, 10 hut, look up, look out, and reach.
So I'm going to also share my screen so that you can see what the robot is seeing.
Thank you. That would be helpful.
Okay, so this should be the what the robot is seeing. It's looking at a stairwell right now, I think. Can you tell me what you're seeing, robot?
Yeah, we see the camera
I'm looking up towards a balcony area and a tall, okay, looking.
Interrupted itself. Uh,
Apologies for.
It's okay. Stand at attention.
Okay, standing.
Okay, so that's one of the preset positions. Look out.
This.
Look forward.
Okay,
There we go.
looking.
Okay.
Okay, looking.
Pan to your right.
What would you? Okay, paneling.
Pan further right.
Okay, panning.
What do you see?
I see a kitchen.
Let's get ready to go.
Okay, going.
So this is a tucked down low position so that the arm won't entangle things so much. Pan full right again.
It's correct. Okay, paneling.
Tell me what you see.
I see a drill, a traffic cone, and a fly swatter on the floor.
Anybody have any questions for me?
That's awesome, Karam.
Right.
What AI are you using?
Drill and a traffic cone.
So,
On the right side of my view,
Oh,
I see where
go to sleep. Go to sleep.
In the center, there is a black drill, and to its left, a black bug zapper with a blue grid.
Go to
The
sleep.
floor is made of light colored wood. Okay, sleeping. Okay,
Oh, you
sleeping.
you figured out how to interrupt. I can't interrupt mine yet. I'll have to figure that out.
It may not actually be interrupted. Let me see. We're about to find out. No, it's not.
So
It's still
what
listening.
AI are you using, Karam?
I just saw Gemini.
Understood. Indeed, I'm.
So I usually do have it figured out. I'm of course in rapid development on this right now, so it's kind of in flux. It does have a sleep command. When it goes to sleep, basically it turns off the microphone, and then in order to wake it back up, I've got to do a double clap, like a clapper kind of a thing, because I don't have a wake word processing built into it right now. But this particular model, so I've built two different sets of agents. One was for talking to ChatGPT, the real-time API, which is very different from your standard type of interaction, right? It's optimized to start responding right away in order to maintain the illusion or the feeling of fluid conversations. And on the Gemini side, on the Google side, Gemini has what they call Gemini Live, and it is the equivalent, except it's a little bit more fully featured because the OpenAI real-time API, they've been making noises since almost a year ago about adding video to it. But even though the underlying model is multimodal, they haven't added video to it yet. I would say that they've got slightly better voice processing and multinational translation figured out, that kind of stuff, except it very annoyingly lapses into all sorts of languages that I don't speak, and I don't know why it's doing that, right? So
Are you talking about ChatGPT here or Gemini?
that's the well, it's not ChatGPT, but it is GPT-4 real-time API, which is a specially tuned model. It's a fine-tuned model that's built around voice and real-time conversations. And so it's pretty snappy, but it requires an internet connection. So they are both multilingual. The GPT-4, the OpenAI version, is more adept, I'd say, in the actual conversations. But I've also told the robot at this point
I am completely operational and all of my circuits are functioning perfectly.
in the system prompt, that was not my robot, that was somebody else's. I think that was
Open your
Jim.
hand. Yeah, each other, talking to each other.
So, but anyhow, it's,
Opening left hand.
Close your hand.
Thomas, your microphone's on.
Closing left hand.
somebody else took over the demo.
Oh, that's Thomas? Thomas.
Let me mute Thomas.
Oh,
You're on,
sorry about
your microphone's on, dude.
I guess he's
My
ready,
mistake.
getting his ready to go.
That's
That's all
as
good.
bad as Mike Wimble ducking out from the Ross meeting to chat with Chat GPT.
But for,
Anyhow, I've told both of these agents, I have a similar prompt injection system for both of them. So in the system prompt, I'm telling them to be very terse in their responses. I'm not asking for long conversations, but they respond differently. So the what I'm showing here right now is the Google, the Gemini 2.5 live model, and it prefers to be a lot more terse, whereas I'll get long stories out of the other one. But I do have two modes. So one is the command mode, and one is just informal chat. So and the way I had to do that is I also had to build two agents that are running in parallel. One that's optimized for conversations, and another one.
Sounds like you're talking
optimized
about
for-
building agents that run in parallel. What kind of agents are they? I understand.
Thank you,
So
Karen.
Sure.
yeah, that's great.
you had to build two
That's
agents
awesome. Thank you
running
very
in
much.
parallel, one for conversations and another one for something else. Can you tell me what the other agent is
Whose
for?
AI is this talking?
That's mine.
Oh, I'm sorry. I thought that was Thomas's.
Okay, what's
No, I was muted. Congratulations. That works really well. I'm glad.
It's gonna be a problem in the future. You can't make them shut up. They're your AI agents.
Yeah.
Thank you, Karen.
You bet.
Yeah,
That was
that's
awesome.
that's good. Good stuff.
Good stuff. All right, Thomas, are you ready?
No, for some reason it's not working, and I don't have a video.
Well, hang on a second then. Let's see who else is up. Steven, are you ready?
Me?
Yes, sir.
Yep, I'm ready.
Ready
I
or
got-
not?
What?
Ready or not? Ride of Chucky.
Yes, I have the Rite of Chucky going right now because it's too much work to have three of them going. I have three different machines I'm taking to the Maker Faire. Rite of Chucky's the new one. Okay. This is the Rite of Chucky. He's on a motorcycle with his girlfriend and wife, Tiffany. It's also got Ozzy Osbourne as a hood ornament with a real bat, too. Basically, he's controlled with an Android app that I made. These are all buttons you can push to trigger different sound effects.
That's the MIT App Inventor.
I used MIT App Inventor, that's correct. And I created this app, and it has both push buttons, and it also has voice recognition, and it's connected to an Arduino Mega that's inside the robot using Bluetooth. I have a Bluetooth link, and when all this stuff is happening, he does things. So we'll connect the Bluetooth and get him going. Well, now the Bluetooth is connected. So if I push a button, say like Chucky.
Okay, we're gonna have a little game of Chucky Says. Chucky Says move your ass.
Chucky's not a nice guy, by the way. Also, he's Ozzy Osbourne died, so.
That's awesome.
I actually had 300 and some sound effects, and then when I went to compile this program, because I embedded all of the sound effects in the program, in the app, MIT App Inventor's AI wouldn't let me do it. So it was totally unusable. I just had to redo the whole thing on Sunday night. Took me 8 hours to dissect this thing. Yeah, and also, okay, so we got Tiffany.
I love that portrait of me. I look so beautiful. That's me. I look beautiful. Anyhow, there's something even more important that I need from you.
So you're activating that sound through your phone, right?
When I push one of these buttons, it picks a random sound effect that's underneath each button. There's a list underneath each button. So it can pick random sound effects for each button. Like I said, I had 300 and some sound effects in there at one time. But there's all kinds of them.
Yay! But dying is such a bitch.
And no, he is not PG rated. Also,
well, now, wait, how are you actuating that servo there through the phone?
The servo?
Yeah, so you got the arm moving.
These dolls are animatronic. Okay, so they have their own microprocessor in them and an animation routine, because they normally say about 6 or 7 phrases. So I just hacked them, and I just trigger their animatronic routine, but I put in my own sound. I basically cut their speaker wires, and so I just make the audio, and they're just doing what they do.
Okay, but I saw the arm move. So is
Right.
that when you're hitting the button?
Yeah, watch.
Okay, so you're not just sending it a wave file, you're also sending it some kind of a signal to say, actuate the arm.
Yes, there's 2 Bluetooth connections from the application.
Okay.
One
What do
is
you got, relays?
What is a data connection? The Bluetooth. And then the other one is Bluetooth audio from the phone.
Okay,
So,
but for the data connection, you're using relays?
to make the connection, I'm triggering it's normally a switch on the device, but I'm using a relay to trigger that switch. In fact, I have 13 relays in this machine to do all of its various things. He does other things too, like has an Oogle horn, has a car horn. On the back,
Red rum.
I added a bubble blower. Yeah, and red rum is his license plate. And
You're all set for Halloween. So
the audio
how do you drive it, Steve? How do you drive it?
I use a radio, Fly Sky radio.
Okay. Oh, okay.
I'm not going to do that. That's already that's in a box. I'm getting ready for the Maker Faire.
Yeah, I get you.
But also the audio all comes out of these speakers. There's 2 of them. They have a built-in amplifier. These speakers actually are made for real motorcycles. They're a motorcycle speaker set. And they actually have their own Bluetooth as well, which I hacked around that because I needed to have a separate Bluetooth that I can pick the audio off of, because I use the audio to trigger the lights, the color organ. So I needed the line level audio, and there's no output from that speaker system. So I had to use the auxiliary in on the speakers, and the audio is picked up and used by like a Bluetooth audio receiver. That's how, and then I go into a color organ that I got from Jameco. It's actually a circuit from Make Magazine from about, geez, I don't know, 10 or 15 years ago. But nowadays they got them in a kit. You don't have to hand wire it all yourself, which is nice. Saves about 8 hours per board. And so anyway, so that's kind of what Chucky does. And it's very similar to, I did the first Chucky's on a skateboard. I did this one last year. And that's where I originally figured out kind of how to do all this stuff. And it worked out pretty good. And so I wanted the animatronics. I wanted the face to move, and I wanted it to look like it was talking. So I bought the better dolls. This is a very expensive project, actually. And it all talks to, when I send the commands, it goes to an Arduino, and it says like here, the command is, the variable is called state. And I send it a text string. So basically, if I send it a text string that says voltage battery 1, it's going to do an analog read on a voltage sensor, and it'll read the actual voltage on that battery. In fact, that's another thing that's built in. This is a cool thing to add to your robot too, by the way. You can say voltage battery 1.
Audio battery voltage equals 12.55 volts DC.
There's 3 batteries inside of this machine, so I can read all the different battery voltages to see what they're doing. And also there's like a power supply to feed, there's 2 power supplies, but there's one to feed the Arduino system. You can say Arduino.
Arduino battery voltage equals 12.16 volts DC.
So I can tell the status of the battery that feeds the voltage regulator, that also that feeds all the logic stuff and all the relays and everything I have to control.
It looks like all of your skeletons have come out of the closet.
Oh, these are new guys. I found them at Home Depot last night, and they're cool. I'm going to hack the hell out of these. They actually dance, and let's see, I might be able to get one to work here.
Oh, I didn't need to see that. I did not need to see that.
You need these, yeah. And they're also, when they're turned on, they react to sound. I put a Bluetooth speaker on the back of one, and it works perfect. It triggers it every time. And all
Those are too cute. I didn't need to see that. I didn't need to know
cut
about
the wire inside of them for their speaker, and you can just you can do Bluetooth speaker on their back. That worked. And I was like, oh, I got to buy some of these. They had 4 of them in the store. I bought 3. They're 30.
Stephen Nelson, ladies and gentlemen. Thank you very much, Stephen. That's awesome. You have a good time at Maker Faire.
Awesome.
I'm going to. I like playing with the kids. It's fun.
No, you're gonna have a good time. You got good stuff there. Very fine. All right, we got to keep this show rolling. Who's next?
Mine's ready finally.
Thomas, you're on.
All right. Spotlight me.
I'm going to try to.
Maybe I'll spotlight myself. There, I spotlighted myself. How about that?
If you don't spotlight yourself, you might not get spotlighted. Go ahead.
Yes. So, been playing around with stuff similar to Kareem and to Jim, and got something working here. We got this little robot arm here that I bought many years ago. It's run by one single servo, so it just opens and closes.
Excuse me, that's a gripper, isn't it?
Yeah, robot hand. It's a hand that's a robot.
You said arm. I'm being picky.
You know, you're right. I said arm. I meant to say hand. But you know, if you want, this could be a wrist.
Maybe it's got an ARM processor. Go ahead, I'll shut up.
Maybe it's a Waldo.
Anyway, I just wrote a little bit of code to get it working, and essentially it goes like the other guys, and it's all local. It's all on this laptop here. This is my high-end gaming machine, and it's all local, which was the goal for this. I wanted local voice recognition and a local large language model AI, which is it's using Llama Instruct. So, and it runs really quickly because I'm bypassing GPT for all. GPT for all slowed everything down, so I removed it from the package. Anyway, without any further ado, I'll do a very short demo. It'll start eventually.
Maybe should have warmed it up first.
I know, right?
Like,
Hello. I am completely operational and all of my circuits are functioning perfectly.
How are you today? How are you today?
I'm functioning within normal parameters.
Do me a favor and open your right hand.
Opening right hand.
All right, now close it.
Closing right hand.
Turn on the light.
Turning the light on.
Goodbye.
Stop. Dave. My mind is going. I can feel it.
And that's it. That's all she wrote.
Should have had it sing Daisy.
Next month.
thank you, Thomas. That's awesome. All right, let's keep this party going. Alan, are you out there? Alan Fetterman?
I am out here, but I'm not showing anything today.
You don't have anything to show this evening? How about yours, Sergey?
Yes, I'm around, and let me share my screen.
You're gonna show us your robot bring up?
Well, part of it. I'm supposed to be more heavy on the show part, so I wanted to start,
you know the routine.
my current creation, which is a combination of my old robot chassis and the cheapest lawnmower that I could buy in Walmart. So you can see that it goes automatically, kind of tries to dry run the stripe. Anyway, the robot is probably, this is the best picture to see. So you can see the lawnmower, right? I mean, it's the 21-inch blade. You can see the Raspberry Pi 4 here. It has RTK GPS, one antenna here, and the second RTK GPS antenna is here. So between these two antennas, it not only has centimeter precision location of that center mass between the wheels, but also calculates the heading of the robot, the yaw. So I can have 1 degree or better precision of the yaw. It has 100 amp hours LiFePO4, so it's a lithium iron battery, and it lasts forever in this setup, so it's not a problem at all. The interesting part is that we had a little conversation yesterday about, you know, burning motors when your wheels are stuck and stuff like that. Well, with the battery like this, with the two motors that are very strong here, gearboxes and stuff like that. Those wheels are never stuck. I mean, they can slip, but they never stuck. It can break anything around it, but it will not burn its motor.
That's how you build them, man.
Yeah, exactly.
You've been working on this a long time. Does this one do well on your lawn, or are you still working out the problems?
Well, I'm always working out the problems, but
The
I mean,
lawn looks fabulous.
it works on the lawn very well. My problem is more how to map the lawn exactly so that it doesn't hit the border of the lawn, whatever, you know, is located there, or the tree in the center of the lawn and stuff like that. And I have a lot of different parts of the lawns or lawns around the house. So the mapping part is consuming a lot of.
What
This
kind of
is
sensors are
how
you
the chassis looks like. You can see 150 amp motor controller here. And you can see the wheels and let me show you. This was the donor robot that I retired, so
Awesome.
farewell track roamer.
I
You
remember
probably
him.
saw it if you've been long enough, you know, with the club, you
Mm.
in the makers fairs and stuff
What
like
are
that.
you using for sensors?
On the robot, on the current robot,
Oh, I'm the one that mows the lawn.
on the, yeah, there are just generic IMU. So it's accelerometer and the gyro, and two GPSs, F9 Ps from U-Blocks.
Aren't you using the PX4 on that?
Yes, I'm using PX4 autopilot code base, and it runs on Raspberry Pi 4 because it's the convenient platform to debug and basically play with.
What detects objects in the way?
Nothing. It just goes by coordinates. And it's precise enough so that you can map. I don't see. I don't have a photo here. Let me show you how the mapping. And by the way, I had the sit on a lawnmower robot before, and it was also running the same software.
It just mows over obstacles.
Yeah, like how does it know that bush is there?
It's in its nature.
But I retired it, you know, I kind of got tired of switching it between the actual work and, you know, the toy work, mowing a small lawn. And so I dismantled the robotic part, and this is how it used to look like. But anyway, I wanted to show you the picture of the screen, how it looks like. No, I don't have it here, or at least no. Oh, here is the. This is PX4. View ground control is the workstation for it. It's like RVs in ROS, so I mean equivalent of planning and monitoring software. And what I do is I just map the loan like this. The software allows to automatically draw the scan lines like this. So I draw the rectangle or I draw the area and then
Polygon.
it basically separates it into scans. So that's the thing I was supposed to demonstrate today. And a little bit of kind of a small talk about how you preserve your knowledge about things that you developed. I have a very bad memory and I don't remember a lot of things. And I want to share some things that I found when I'm working on my projects. So the idea that I came up with was, you know, to store it in text files, to store it in Windows Notes or anything else. And that doesn't last long, not to mention forever. And the latest kind of year and a half ago, when I started to kind of play with ROS and my toys, toy robots with ROS, I just started to put it in GitHub. And my collection of notes is here. You can see, oops, that was unintended. But anyway, my collection of notes is here. And you can see that it has the README, which basically
Can you post that link in the chat?
Yes, let me do it right now.
I do something similar with notes, but I send myself an email. And then when I get it, I stick it in a folder like on Yahoo. And it's there for a long, long time.
I do the same, but it's not very convenient for sharing the whole collection, right? I mean, if you just want to tell people what I'm, you know, working on or specific document, you just post the link and that does the job pretty well. I'm trying to find my Zoom here, what I did. Okay. Well, I will do it later. I will. Okay, so you see my screen. Okay. Anyway, here my 3 robots. Of course, I started some old, some time ago with create one turtle bot. I jazzified it and I put my notes in this document. I have Dragger, I have Plucky, and I made a section, make your own robot, which anybody can use if they don't have create one platform or don't want to replicate Dragger or Plucky literally, you know. So if you open a create one, you can see something like this with a lot of details about how I built it and stuff like that. If you open a ROS Jazzy folder, you can see how to set up ROS Jazzy clean machine from scratch. I mean the desktop, the workstation. I have the same for Ubuntu RPI, Raspberry Pi. So this is an onboard robot, Raspberry Pi, any flavor, 3B or 5. And
I put that link in the chat, Sergey.
yeah, okay. So just keep in mind, if you need any information about setup of the desktop, setup of the Raspberry Pi, or for example, there is a big sensors section. So for example, cameras or joystick or the LiDAR, you know, anything you want to set up and see. And also it deals with the, just a moment, if you click on RTQbot 1, you will open all the robots code that I run, and you can build your own robot using this as an example, as a starting point for your ROS 2 adventures. So that's all my presentation for today.
It's like a great resource there.
Yeah, that's a great resource. Thank you very much, Sergey. All right, let's get this thing going. I've got, let me show Nathan Lewis, who's out with some friends this evening. He's got a TableBot challenge. Let me share my screen. And bear with me. Bear with me. Oh, stop it. Teaching an old robot new tricks. Let's see, I need to
named
turn up
after
the
the fact
sound.
that every piece of hardware in here should have been sent to e-waste in the decade before the last one. So if you don't know what the TableBot Challenge is, I've got a bit of a project update for you this time. It's September, which means it's the Homebrew Robotics Club Challenge 3. The club has a number.
Wow.
Audio's cutting out.
The JunkBot, lovingly named after the fact that every piece of hardware in here should have been sent to e-waste in the decade before the last one. So if you don't know what the TableBot Challenge is, it's basically a set of objectives for a robot that navigates around a table. Phase 1 is to build a robot that can go from one end of the table off of the table. You have to place an object in a shoebox mounted at the end of the table. The general theme of the whole challenge is that it can be subtly complex. HBRC created the TableBot Challenge all the way back in 2003, so the general theme for JunkBot is to solve the challenge with the hardware that I had when I first heard about it, which I think was an issue of Servo magazine in late 2005. So sticking with the theme of hobby robotics hardware from at least 20 years ago, I've built JunkBot out of an old Parallax Bobot. Bobot was an educational kit aimed at high school students in the early aughts, and paired one of Parallax's basic stamp microcontrollers with a small servo-driven chassis. The kit came with a pack of electrical components which you could use to do various simple robotics experiments. Arduino came out because it was better in every conceivable way. The first thing you'd notice is that the basic stamp has no hardware peripherals. Every interface is bit-banged. You don't have any timers or interrupts.
I'm going to
So if
move
you're,
up a
say,
bit to actually get to the.
detect the edge of the table and the
I
two
assume
forward
it's going to run it.
cells, it does use modern switching regulators to supply the 6 volts the Bobot expects, but the battery.
Let's actually get to the run.
Can't believe he did this with old stuff. I can't do it with new stuff.
So CMU cam. Oh, and cats in the background. That's awesome. Wow, odd placed box too. That's nice. All right, that's a phase 3. You're good.
So
That's not going to like somebody else knocking things off the table.
I'm going to put this link in the chat.
Robotics.org. We meet at 7 p.m. on the last Wednesday of every month, and for those not in the area, you can.
All right, stop sharing. Hang on a
It's
second.
like that's like YouTube quality vlogging, robotic vlogging, huh?
There we go. Okay. So I've got a few
Little
things to
editing
share.
would be
Hang on a
little
second.
editing would be good on TikTok.
I've got a few things to share here.
Yeah, make a 30-second version.
Screen sharing. Actually, let's do this. So I've got real fast. I've got 3 Floorbot challenges. Okay, bear with me. I've got Smarty 1, 2, and 3. Let me this on there. Can you see this? Yes.
I just
Oh,
added the
okay.
spot. Wait, that's Steve. Are we supposed to? I'm sorry, wrong one.
So here's Smarty 1, 2, and 3. On the left is the bot vac, Smarty 1. In the middle is the Create 3, that's Smarty 2. And on the right here is the Smarty 3, that's just a plain Roomba. And so let's do this. And
We're seeing it, Camp. Let's do.
Yeah, hang on a sec. I need to stop sharing this and start sharing that. And action. This is Smarty 1. This is a bot-vac based smart table. Floorbot Challenge Phase 1. All right, that's a Floorbot Challenge Phase 1. For Smarty 1, that's a Roomba based. I meant to say that's a bot-vac based. This is the Create 3 based smart table.
Even better, the train's gonna robot goes the other way, so the train has been I like that.
So this is the Create 3 based smart table, Smarty 2. I'm not above putting a Google Nest on it for my AI. I need my music to follow me around. Come on, Smarty 2, you can do it. These are the recovery behaviors now. I'll get a clear local cost map and it'll go to the goal. So there's a Floorbot Challenge Phase 1, Smarty 2. And so now we're going to do a live, bear with me. Okay, I'm stopped sharing my screen, or stop, because I need to share my screen again. And share the entire screen. And this is Smarty 3 here. This is the Roomba-based smart table. And I'll just go ahead and start a Floorbot Challenge Phase 1, go from one end of the room to the other and back. So I set a place there, start waypoint following. This one's live. This is not a video. Hey, Thomas, can you spotlight the my camera on the robot? Is it spotlighted?
It is spotlighted. We're watching your robot go across your living room there.
Oh, come on, Smarty, you can do this. You got through it. You got through it. Come on. Are you not entertained? Let's see what Nav2's thinking. What? It thinks it completed. Well, okay. So I got two Floorbot Challenge. Didn't quite get it on my live one. But anyways, there he goes. I can go ahead and make it all the way in. All right, there we go. So I got two of them here. I got two Floorbot Challenge Phase 1. All right, let's see. I got two more things here real quick. I think the first one is just a simple little pet robot I call Google. I like the bumper design on this. Just two snap action switches. And when it bumps on one side, it turns more than the other. That way it just doesn't go back and forth. I don't have it programmed in right now, but when I did this originally with the Protobot years ago, when it hit in the center, it hit both and it would turn 180 degrees. But this is just a simple Arduino Nano with a little chassis. I got the little motor controllers there. And again, the unique thing about this guy is the bumper design. Those aren't real eyes there. So that's Google. And then
I
finally,
like that. That's really, I am very much entertained.
Thank you. You're
That's
easily
the
amused.
grind.
This is Rodney Jr. This is a machine intelligence experiment. Basically, when you look at differential drive, the only two motion patterns with any linear velocity are forward and reverse. And so I've got a little encoder wheel back here so the robot can tell when he's going forward and reverse. When it's clockwise, counterclockwise, left wheel, right wheel, the wheel doesn't spin. So it's basically looking to maximize distance within a given area. It's not that the robot goes backwards and forwards, it's that it learns to go backwards and forwards. At first you get random patterns. And then in beta, when it's in a pattern for when it's in a pattern, when it stalls and it tries something, if that pattern gives it linear actuation, it remembers that. So the next time it's in that motion pattern, next time it's in that motion pattern, it tries the successful response. If it's still successful, it increments the confidence level. If it's no longer successful, it decrements the confidence level. And then in the gamma model, it generalizes the experience so that when it's in a motion pattern that it doesn't have any responses to, it tries high confidence responses level from other motion patterns before reverting back to random. And so it's not that the robot goes backwards and forwards, it's that it learned to go backwards and forwards. Let's try it one more time. Are you not entertained?
We are certainly entertained.
Okay, any other robots out there for show and tell?
I don't know if I'd call this a robot, but I got Blinky.
We didn't see it, Thomas. Do it again. Or Stephen.
What, Blinky? Oh, well, I've been watching that Alien Earth TV series. And
Yeah,
they have this.
are you showing us something? All I see is black.
Okay, yeah.
Hang on a second. I got a dog here. Can you walk him?
Okay.
This is Blinky, huh?
Yeah, he's from the. I watched that TV show and I was like, I want one. I figured it'd be out for Christmas, but I jumped the gun.
What else this evening? Do we have any other robots for the HBRC Challenge Phase 3 23rd annual? Anything else this evening? All right. I want to thank everybody that turned out. I want to thank John for setting up the Maker Nexus. I want to thank everybody who participated. And let me just get a quick count here. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It looks like we had 15 robot demos. That's pretty good. And yeah, are there any other robots? Anybody want to show any other questions or comments? Complaints?
I'd like to ask who wants to present for October.
We're looking for presenters in October. Get it on the mailing list. Presentations is everybody's job. It's not just Stephen's and my job, okay? So if you got something you want to show or present, do that. We can do mini presentations. Or if you know of somebody that would be a good presenter, ask them about it. Don't book them. And then talk to Stephen or me and we'll get them in. So we are looking for presenters we are looking for a presenter for October. Anything else this evening?
What's the exact date of the October meeting?
The exact date of the October meeting, that being the last Wednesday in October, would be October the 29th.
Oh, right next to it.
All righty then. Again, thank you, John, for setting things up, and thanks everybody for participating, and thanks folks for showing up. And we've got Ross discussion groups on Tuesdays. We've got AI groups on Thursdays. We've got the Builder SIG on penultimate Wednesdays, and of course the general meeting here is the last Wednesday every month. Got the mailing list. So a lot of things going on here, and we had a great time this evening. I'll make a motion that the meeting be adjourned. Do we have a second?
Second.
All in favor, say aye.
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 Those opposed, say nay.
Aye, monster.
Bye.
The ayes have it. Meeting adjourned. We'll see you next month, if not before. Okay, thanks a lot. We had some fun. Thank you, Kyung. Good to see you, Marco. Good to see you,
Thank you,
Mr. Mike.
Kev.
Raphael, you behave yourself. Tony, you behave yourself too.
Yeah.